Hari Om. Hello everyone, I am Sri Jyoti. Welcome to my channel. Today's video is of chapter 4 complex numbers and quadratic equations. We have studied linear equations in one variable and two variables and quadratic equations of one variable. Here we have seen that x square plus 1 is equal to 0 has no real solution. Because x square plus 1 is equal to 0 gives x square is equal to minus 1. That is, x is equal to square root of minus 1. So, it's not a real number. Okay. So, here a number that is square root of minus 1, it is denoted by I. Okay. We denote it by I, an imaginary number. Okay. Therefore, I is equal to square root of minus 1. So, I square is equal to minus 1. Therefore, here what is the solution? X square plus 1 is equal to 0. The solution of x square plus 1 is equal to 0 is I. Okay. That is x is equal to square root of minus 1. So, we denote it by I, an imaginary number. Therefore, the solution of x square plus 1 is equal to 0 is I. Okay. So, a number of the form a plus ib, a number of the form a plus ib, where a and b are real numbers, is defined to be a complex number. Okay. A number of the form a plus ib, where a and b are real numbers, is defined to be a complex number. That is, a complex number is of the form a plus ib. Here a and b are real numbers. Okay. So, we denote a complex number by z. Okay. So, z is equal to a plus ib. It's a complex number. So, here that is first term, okay, a is called real part of z. Okay. It's a real number. It's called real part of z, denoted by Re of z. Okay. And here b is called imaginary part of z. Okay, b is called imaginary part of z, denoted by Im of z. Okay, here a is called real part of z, b is imaginary part of z. Here why? Because I is an imaginary number. Okay, so for example, z is equal to 3 plus I5. Okay, z is equal to root 2 plus I root 7. Okay, because 3 and 5 are real numbers, root 2 and root 7 are real numbers, any number. Okay, z is equal to 1 by 5 plus I 3 by 7. Okay, etc. And next, see, let us take two complex numbers z1 and z2. Okay, let us take two complex numbers z1 and z2. z1 is equal to a1 plus ib1. z2 is equal to a2 plus ib2. Okay. See here, if these two numbers are equal, okay, that is, if z1 is equal to z2, that is, a1 plus ib1 is equal to a2 plus ib2, if and only if, okay, two numbers are, that is complex numbers, two complex numbers are equal, if and only if a1 is equal to a2 and b1 is equal to b2. Their real parts are equal and imaginary part of complex numbers are equal. Okay, a1 plus ib1, okay, is equal to a2 plus ib2, if and only if a1 is equal to a2, b1 is equal to b2. Let us take one example. Here z1 is equal to x plus I3y is equal to 5 plus I18. Okay. See, these two complex numbers are equal. So, what is the value of x and y? Okay. If these two are equal, then what are the values of x and y? See, we have studied a1 plus ib1, that is if two complex numbers are equal, if and only if their real parts are equal and imaginary parts are equal, right? So here, so x is equal to 5, okay? If these two are equal, then x is equal to 5, and what is the imaginary part? 3y, right? So 3y is equal to 18, that implies y is equal to 18 divided by 3, that is 6. So x value is 5, y value is 6. Next we will study algebra of complex numbers. Algebra of complex numbers. First one, addition of complex numbers. Okay. First one, addition. Okay. Here we will take two complex numbers. Then what is their addition? Okay. So z1 is equal to a1 plus ib1. z2 is equal to a2 plus ib2. So what is z1 plus z2? z1 plus z2. Here z1 is nothing but a1 plus ib1 plus a2 plus ib2. Okay. So here what we will do? See, we will add first real parts. Okay, that is real part of z1 and real part of z2. Okay, that is a1 plus a2 plus, okay, next let us take together of imaginary part. Okay, so b1 plus b2, that is I b1 plus b2. Okay, see, a1 plus a2 plus I b1 plus b2. See, it is of the form a plus ib, isn't it? A plus ib. So it's also, which is also a complex number. Okay. So z1 plus z2 is also a complex number. So next, subtraction. Here also z1 is equal to a1 plus ib1, z2 is equal to a2 plus ib2. Let us see what is z1 minus z2. Okay, subtraction of two complex numbers. a1 plus ib1 minus a2 plus ib2. Okay, that is equal to, here a1 minus a2, let us take real parts together. Okay, so a1 minus a2, okay, plus here ib1 minus, see, we have to apply this minus these two terms. Okay, so plus I into b1 minus b2. See, here also, now it is of the form a plus ib. So z1 minus z2 is also a complex number. Next, let us see what about multiplication. Multiplication of two complex numbers. See, z1 is equal to a1 plus ib1 and z2 is equal to a2 plus ib2. Now what is z1 into z2? z1 a1 plus ib1 into a2 plus ib2. Okay, let us simplify this one. a1 into a2, a1 into a2 plus a1 into ib2, that is I a1 b2, okay, plus I b1 a2, I b1 a2 plus I into I square b1 b2. Okay. So next step, a1 a2, write as it is, plus, see here in these two terms I is common, so we can take it out. So take it out, I a1 b2 plus b1 a2 plus I square. What is the value of I square? I is equal to square root of minus 1. So I square is nothing but minus 1. So minus 1, that is minus 1 into B1, B2. Okay? Now, see, let us write first term and third terms are real parts, right? So A1, A2, let us take it together. Write A1, A2 minus B1, B2 plus I into A1, B2 plus B1, A2. Okay? See, now it is of the form A plus IB. So which is also a complex number. So multiplication of two complex numbers is a complex number. Then what about division? Here division. Here division, how we will write? Z1 is equal to A1 plus IB1. Z2 is equal to A2 plus IB2. Okay. So Z1 divided by Z2 is equal to A1 plus IB1 divided by A2 plus IB2. See here, we cannot simplify, right? So before that, we have to make this denominator in the form of A plus IB. Now see here, first of all, we have to make the denominator in real number. Okay, let us see how. We have to make this denominator in real number. Okay, for that we will multiply. Okay, we will multiply and divide by A minus IB2. That is Z1 divided by Z2 is equal to A plus IB1 divided by A1 plus IB1. Okay, A2 plus IB2 into, okay, divide, multiply and divide by A2 minus IB2. So you will understand why multiplying this term A2 minus IB2 divided by A2 minus IB2. So that we will get the denominator a real part. Okay. Now simplify. Here, okay. A1 plus IB1 into A2 minus IB2. Simplify. A1, A2. A1, A2 minus I A1, B2 plus I A2, B1. A2, B1 plus into minus minus I square, I into I square, B1 into B2. I square, B1, B2 divided by, see here, now it is of the form A plus B into A minus B. It is of the form A plus B into A minus B. What is A plus B into A minus B? A square minus B square, right? So A square, that is A2 square minus B square, that is I square B2 square. Okay. Here B means IB2. So I square B2 square. So next term, next step, okay. Here A1, A2 plus, take I outside, okay, second term and third term have I common, okay, so take I outside, so I into, here let us write this one first, okay, because it is plus, so A2 B1 minus A1 B2, here I square value is minus 1, so minus 1 into minus, that will be plus B1 B2 divided by, here A2 square, here also I square value is minus 1, so minus 1 into minus, it will become plus, So a2 square plus b2 square. See, now it become a real number. Okay, no imaginary part, isn't it? Okay. Then next, okay, let us write the real part together. That is a1 a2 plus b1 b2 plus I into a2 b1 minus a1 b2 divided by a2 square plus b2 square. Now we can write it as, once again, one more step, okay, a1 a2 plus b1 b2, it's a real part, okay, divided by a2 square plus b2 square plus I into a2 b1 minus a1 b2 divided by a2 square plus b2 square. See, here, now it is of the form a plus ib, okay. It's a real number. It is also a real number with I. Okay. So, it's real part of Z, real part of Z1 by Z2, and it is the imaginary part of Z1 by Z2. Therefore, see, it is also in the form of a plus ib, which is also a complex number. Okay. Therefore, division of two complex numbers is also a complex number. Next is power of I. We know that I square is equal to minus 1. Okay. Then what is I cube? I cube is nothing but I square into I, that is minus 1 into I, that is equal to minus I. Okay. Now what is I raised to 4? I raised to 4 is nothing but the square of I square, isn't it? What is the value of I square? Minus 1. So minus 1 square is 1 plus 1, right? Then what about I raised to 5? I raised to 5 is nothing but I raised to 4 into 1. Okay, that is, sorry, I raised to 4 into I. I raised to 5, that is equal to I raised to 4 into I, that is I raised to 4 is nothing but 1 into I, that is I. Now what is I raised to 6? I raised to 6, how can we write? We can write it as I square whole cube. Okay, cube of I square, that is I raised to 6, 2 into 3. Okay, so what is I square? Minus 1. Minus 1 raised to 3. Okay, since it is an odd number, okay, if power is an odd number, then the value is minus 1. Okay, so minus 1 raised to 3 is minus 1. Then I raised to 6 is equal to minus 1. Okay, then what about I raised to 7? I raised to 7 is nothing but I raised to 6 into I, isn't it? What is I raised to 6? Minus 1. So minus 1 into I minus I. Again, what is I raised to 8? I raised to 8 is nothing but I square raised to 4. Okay, 4 into 2, 8. So I square is minus 1 raised to 4, since it is an even number. So minus 1 raised to 4 is 1. Okay, plus 1. See here, I raised to 4 is equal to 1. So I raised to 8 is equal to 1. Then what about I raised to 12? That is I square raised to 6. It is an even number. Therefore, here also we will get 1. So I raised to 4 is equal to 1. I raised to 8 is 1. I raised to 12 is 1. So we can say that I raised to the power of I, if the power of I multiple of 4, then its value is 1. Okay. If the power of I is a multiple of 4, then its value is plus 1. Okay. Then I raised to 4k plus 1 is equal to 1 into I, that is I. So remember, I raised to 4k is equal to 1. Okay. I raised to 4k plus 1 is equal to 1 into I. Okay. So no need to memorize, you can find it very quickly. Okay. So if you know this one, I raised to 4k, that is power of I. If the power of I is multiple of 4, its value is 1 plus 1. Okay. And I raised to 4k plus 1 multiply with I, that you will get I. Okay. So next I raised to 4k plus 2 multiply again with I. Okay. That is I square is minus 1. Okay. So I raised to 4k plus 3 again multiply with I. So you will get minus I. Next I raised to 4k plus 4. Okay. It will be a number with a multiple of 4. Okay. I raised to 4k plus 4 is nothing but it's a multiple of 4. Okay. So it is nothing but 1 plus 1. So remember I raised to 4k. I raised to 4k is equal to 1. K is a natural number. Okay. Then what is I raised to minus 1? See, I raised to minus 1 is nothing but 1 by I. Isn't it? See, what is a raised to minus 1? A raised to minus 1 is nothing but 1 by a. Isn't it? So, I raised to minus 1 is equal to 1 by I. See, here also, now we have got denominator a complex number, right? Okay, with the imaginary part. Okay. So, here we have to make this denominator as a real part. Okay. So, here for that, what we will do? 1 by I multiply I by I. Okay. 1 by I into multiply and divide by I. So that you will get denominator as a real part. Okay. So 1 into I into I square, that is I divided by minus 1. See, now we have got a denominator a real part. So here that is nothing but minus I. Okay. I divided by minus 1 is nothing but minus I. So what is the value of I raised to minus 1? That is minus I. Then what about I raised to minus 2? I raised to minus 2 is nothing but I raised to minus 1 into I raised to minus 1. That is minus I into minus I. Minus minus become plus. I into I square. I square is nothing but minus 1. Okay. So I raised to minus 2 is equal to minus 1. I square is also minus 1. Next, okay, we will study what is the multiplicative inverse of I. Multiplicative inverse of a complex number. Okay.